Okay, students, today we're going to do part 2 of the test corrections, and this is showing you how to tackle some of the written questions, in particular how to write mechanisms, how to write reactions, and how to explain certain concepts. So let's get into it and tackle these questions. So the first question that I have here is how to write down the mechanism for the nitration of benzene. And before I actually tackle this question, it would be good to know what the reaction of the nitration of benzene is. And in benzene, we use nitric acid and sulfuric acid together with heat. And the result of that is putting a nitro group on the benzene ring. So the mechanism will show us how this exactly happens. So the first thing in this reaction would be to put an electrophile onto the aromatic ring. So it's creation of the electrophile that is the first part of this reaction. And that is normally the reaction that takes place between nitric acid and sulfuric acid. So if I look at nitric acid and sulfuric acid and how they interact, I know that very importantly it takes place between the lone pair on this nitric acid, and that first abstracts a proton from sulfuric acid. The structure of sulfuric acid is this. So this lone pair abstracts a proton from there. These electrons then go toward the oxygen. And note how I show you, because just now I'll show you some papers where some students have answered questions. Note how I show you the direction of the electrons going from the lone pair of oxygen to the proton, and direction of electrons from this bond here to my oxygen atom. So it's very, very clear. And from there, I protonate this nitric acid. So this oxygen now becomes protonated because I've used, remember it had 2 lone pairs to start off with. I used 1 lone pair to form a bond. It just has 1 lone pair now, and if you look at oxygen, there's 1, 2, 3, 4, 5 electrons in the vicinity of oxygen when it should have 6. So it's 1 electron short, so oxygen is a cation. And in the process, I put an extra lone pair of oxygen here in sulfuric acid, and I have a cation and an anion. But the electrophile, you know, we're trying to form a nitro cation, and what happens now is that these electrons go toward oxygen, takes both the electrons to leave as water, H2O, which leaves this nitrogen and electron short, making it your electrophile. Right, so it's NO2 plus ion plus water. And in the second part of your reaction, and this is part of the rate determining step, and notice I kept my charge on nitrogen because that shows you now that this is the electrophile, this is the nucleophile, and this nucleophile now goes and attacks this electrophile, and in the process these electrons are moved, so something's happening here. Remember, there was already a hydrogen on this carbon. We're just now adding a nitro group on there. I've taken electrons away from that carbon atom, and if I take electrons away, I'll be 1 short. So it becomes a cation, and this is my carbocation intermediate. Then you notice that any base can abstract that proton. I re-aromatize for my aromatic ring again and get my product. These electrons here are now there, and you can see that in this mechanism I've got all my intermediates in here. I've got all the charges on my intermediates, right? So I give you marks for charges on your intermediates. I give you marks for getting the intermediate structure right. I give you marks for getting the direction of flow of electrons right, and I also give you marks for the entire mechanism. So you'll find that this is a complete mechanism for the nitration of benzene. So this is question 2a. I think I'll make another video for question 2b tackling that problem.